Alright, so now that we've talked about lines and angles, the things that which make up polygons, now we're going to get into exactly what a polygon is. And here are some pictures of a polygon. And basically what a polygon is, they are closed figures that are made up of 3 or more line segments. And these line segments are going to be straight lines, like so. They are not going to be curved lines. And here, again, here is an example of some polygons right here. And we'll get into exactly what these are in a little bit. Okay? So again, look at this picture here. To tell if the shapes are polygons or not, you have to ask yourself a couple questions. Right here. Ask yourself, is the figure closed? And what we mean by a closed figure is just like this triangle here. All the line segments are connected and there are no openings. If you look at this looks sort of kind of like a rectangle, but you notice that it has an opening in it right here. That's what we mean by an open figure. Okay, a polygon is not an open figure. It's going to have all the sides closed in, such as this one here and the rest of them. Notice these two shapes down here. They are not polygons because they have these curved lines in them. Okay? All polygons are closed figures. They don't have openings in them like this one, and they do not have curves in them like these two. Now polygons, the word poly means many and gons means angled figure. So they are a many angled figure. And we name polygons based on their sides and their angles. Okay? Another name for the angle is what we call a vertex, and that's where the two line segments come together. They form the corner or the angle like we talked about in lines and angles. This right here would be the vertex. Okay, just like these green dots, these are the vertices. Okay, the vertex. And pretty much that is just the corner or the angle of the figure. If you look at the figure down here, this parallelogram, these here are the vertices. Vertices is plural for vertex, or the angles, the corners of the shape. And so polygons, they are made up of line segments and vertices. Okay? Here's that polygon tree. You'll be seeing this a lot in our classroom. And it just shows you some very common polygons, like the triangle. This one here, that looks like a rectangle. We actually call it a quadrilateral. Pentagon, hexagon. Here's an octagon. And basically polygons are named for the number of sides and the number of corners, angles they have. A triangle is named after having 3 sides. 1, 2, 3. Then you have the next one, which is a quadrilateral, which has 4 sides. Okay? And again, they're named after the amount of sides they have and the amount of angles they have. And it's all going to be the same. If a polygon has 3 angles, then it has 3 sides. If it has 4 angles, it's going to have 4 sides. Look at the pentagon. Pentagon has 5 angles or 5 sides. Then you have a hexagon that has 6 angles or 6 sides. And then you have the octagon, which has 8 angles or 8 sides. And these are all the common ones. This next slide shows a few more. Again, we have our triangle, 3 angles and 3 sides. The quadrilateral, 4 angles, 4 sides. You write down the list. the pentagon, which has 5, then the hexagon, which is known for 6 angles, 6 sides, heptagon, here's the 7, skipped over one that last time, the octagon, 8 angles, 8 sides, the nonagon, which has 9 angles and 9 sides, the decagon, which is 10 angles, 10 sides, and so on. Here's 11, 12. Okay, so all polygons are named after the amount of angles or sides that they have. And again, if it has 4 angles, it's going to have 4 sides. If it has 3 angles, it's going to have 3 sides, and so on. The angles and sides always match in the same amount. The most common polygons that we focus on, really, or that you may already have heard of and are most common, are again your triangle, quadrilateral, also known as square, rectangle, and this one right here is really important. I've mentioned it before. This is the one that we're going to spend a lot of time with this year in 3rd grade. In our next lesson particularly, we're going to really look at the different characteristics of quadrilaterals. Not only do they just have 4 sides, but there are other things that are that you can categorize quadrilaterals into. But you have the pentagon, the 5-sided figure, hexagon, 6-sided figure. Skip over the heptagon; it's not too common, and then we move over to the octagon. That's another very common figure. Think of a stop sign. But again, those 1, 2, 3, 4, 5. Those 5 that I underlined are really the most common polygons that you'll be very familiar with. That's why they're back here on this slide as well in our tree that you will see throughout the classroom. And of course, from this tree as well, you can see that this group right here, the quadrilaterals, which I've showed you before, this is the one that we're really going to pay attention to this year in 3rd grade. Over here, you'll get into this next year in 4th grade and really talk about triangles. Okay, but again, here's where we're going to be spending a lot of time, especially next lesson. So again, all polygons are named according to their sides and their vertices. If it has 4 equal sides, 4 vertices, or 4 angles, then it is, of course, a square or quadrilateral. It has 3 sides, 3 corners, 3 vertices, then it's a triangle. 5 sides, 5 angles, 5 vertices, pentagon. 4 unequal sides, 4 vertices. You could call it maybe a rectangle. Really, it's a quadrilateral. It's a 4-sided figure, 4 angles. You'll see next lesson how we categorize a rectangle and how we categorize a square and what makes them so unique. And again, then the last one, if you have 6 sides, 6 corners, 6 vertices, 6 angles, whatever you want to call them, then it's a hexagon. And that is what a polygon is. Remember, all polygons are named based on the amount of sides they have. And if you want to determine if something is a polygon or not, you just have to ask yourself these questions right here. Is the figure closed, meaning there are no gaps? And are all the lines straight? Are they made up of straight line segments, unlike these ones down here? Alright, thanks a lot, guys.